Analog and digital, question 2. A radio station wants to produce high-quality digital signals of sounds of frequencies up to 20 kHz, 20,000 Hz. A. Part 1. What is the minimum sampling rate they must use to ensure this? Well, this question comes up time and time again. You must remember that the minimum sampling rate is at least 2 times the highest frequency in the information you're sampling. So in this case, 2 times 20 kHz is 40 kHz. Part 2. Explain the effect of using a lower sampling rate. Well, there's only one mark for this, so we're not after a huge amount of detail. A lower sampling rate means that some higher frequencies or some peaks and troughs will be lost. In diagram form, a signal like this, where there's a little bit of higher frequency information here and here, may end up becoming something like this, so those extra details have been eliminated. Part B. Explain why they've chosen 20 kHz as their upper frequency. Well, this is the limit of human hearing, so if there are any losses of information above 20 kHz, they will not be noticed. C. Explain using a diagram what is meant by sampling. Now it tells us to use a diagram here, not suggesting we may use a diagram. Therefore there will be marks available for a diagram, and one must appear. There's only 2 marks for this question, however, so we're not after a huge amount of detail. A diagram something like this, with time on the x-axis and binary values on the y-axis, an analog signal which has been sampled at various regular time intervals and binary values assigned to each of those samples. What we've done is we've sampled at regular time intervals and given the closest binary value to each of those. Part D. Apart from sampling rate, what else affects reproduction quality? Well, clearly the more values we have available here, the closer we can get to the actual value of the sample, and so increasing the number of quantization levels would increase reproduction quality.